Right now, in secret labs around the world, scientists are building machines that don't just calculate, they bend reality itself. They're called quantum supercomputers, and they're so powerful that they could break the internet, destroy encryption, and maybe even unlock the secrets of the universe. But before you panic and throw your phone into a lake, let's figure out what these reality-bending boxes actually do. Because trust me, they're not your average RGB-lit gaming PCs. Let's start simple. Your laptop, your phone, even NASA's computers, they all speak the same basic language, bits. Bits are like tiny coins, heads or tails, 1 or 0. Every photo, video, meme, and cat video is built from billions of these tiny yes or no answers. Classical computers are amazing at that, but they have one big weakness. They can only do one combination at a time. It's like trying to find your lost socks by checking every single drawer, one after another. Slow, painful, and full of existential dread. Quantum computers, though, don't search one drawer at a time. They open all drawers simultaneously, and somehow know which one has your socks. How? Because instead of bits, they use qubits, quantum bits. And here's where things get weird. A qubit doesn't have to be just 0 or 1. It can be both at the same time, thanks to something called superposition. Imagine flipping a coin, and instead of landing on heads or tails, it just keeps spinning in midair forever, being both at once. That's a qubit, a tiny rebel defying logic and physics, until you look at it. Then it picks a side. But wait, it gets creepier. Quantum computers also use entanglement, Einstein's least favorite magic trick. Two qubits can become so connected that changing one instantly changes the other. No wires, no signals, just instant connection, even if they're light years apart. Einstein called it spooky action at a distance, which is basically physicist slang for we have no clue how this works, but it does. When qubits are entangled, they start working together, like a synchronized dance troupe of subatomic ballerinas. The more qubits you entangle, the faster and smarter the quantum computer becomes. But here's the catch. Building a quantum computer is harder than explaining taxes to a cat. Qubits are super fragile. Even a tiny vibration, a flicker of heat, or a stray magnetic field can make them lose their quantumness. Scientists call it decoherence, basically the qubit saying, "Ugh, reality is too much. I quit." To keep them stable, these computers are chilled to almost absolute zero, colder than outer space. Imagine a computer that only works if you keep it colder than Pluto. That's quantum computing for you. Now imagine taking thousands of these qubits, entangling them together, and letting them compute all possibilities at once. That's not just a quantum computer. That's a quantum supercomputer, the big boss level. These aren't just theory anymore. Companies like IBM, Google, Rigetti, and even China State Labs have already built prototypes, and they're getting stronger every year. In 2019, Google claimed something huge. They achieved quantum supremacy when a quantum computer outperformed the world's fastest classical supercomputer. Their machine, called Sycamore, solved a random math problem in 200 seconds. A normal supercomputer would have taken 10,000 years. Of course, critics said, "Okay, Google, but can it run Crisis?" Still, the point was made. Quantum computers had officially entered the chat. So, what can a quantum supercomputer actually do? Here's the spooky part. If we ever build one powerful enough, it could crack every encryption system on Earth. Your bank passwords, your WhatsApp chats, even nuclear codes. Gone. Because today's encryption relies on math problems that take classical computers millions of years to solve. A strong quantum computer could solve them in minutes. That's why some scientists call this moment the coming Q-Day, the day encryption dies. So yeah, I agree to the terms and conditions. Might actually matter someday. But it's not all apocalyptic fire and data theft. Quantum supercomputers could also do amazing things. They could simulate molecules at atomic precision, leading to breakthroughs in new medicines, materials, and even clean energy. They could model the climate accurately, predict pandemics, optimize transport networks, and design AI that's far smarter than anything we have today. And here's the twist. Quantum computers could even help us understand the universe itself. See, the laws of physics at the smallest scales, quantum mechanics, are weird, chaotic, and confusing. But if you build a computer that speaks the same language as the universe, you can finally start asking it questions it understands. It's like teaching your dog English so it can finally explain why it keeps barking at the wall. But right now, quantum computers are still toddlers, brilliant, unstable toddlers. The biggest ones have just a few hundred qubits. To truly reach world-changing power, we'll need millions, perfectly stable and error-corrected. And that's not easy. The hardware is tricky, the math is brutal, and keeping the system cold enough to work is like trying to run a data center inside a freezer. But companies are racing. Google, IBM, and startups like IonQ and D-Wave are all trying to scale up. Some use superconducting circuits, others use trapped ions or photons. Everyone's got their own secret sauce. Meanwhile, governments are quietly investing billions. The US, China, and the EU all have national quantum initiatives. Because whoever builds the first true quantum supercomputer wins the next century. It's not just about faster math. It's about power, military intelligence, cybersecurity, artificial intelligence, economy, control. Quantum computing isn't just a new type of computer. It's a new type of reality. Imagine a machine that could predict financial markets, model human biology, decrypt anything, and even simulate the universe itself, all at once. That's not just science fiction. That's where we're heading. And when that day comes, classical computers, the laptops, servers, and phones we use today, will look like stone tools next to a spaceship. But don't worry just yet. We're still in the early stages. The tech is fragile, the machines are massive, and the math is nightmarish. Still, the progress is accelerating faster than anyone expected. It's like watching fire turn into electricity. We're witnessing the birth of a new technological era, one that could redefine everything. Of course, that also means hackers, spies, and governments are watching closely. Some are already storing encrypted data, waiting for the day they can use quantum computers to unlock it all. So yes, Q-Day might sound like a sci-fi movie, but the script is already being written. The good news is that scientists are also working on post-quantum cryptography, encryption methods designed to survive even a quantum attack. The internet might bend, but it won't break. Hopefully, quantum supercomputers are both our biggest hope and our biggest fear. They could cure diseases or crash economies, save humanity or outsmart it. And that's what makes them so fascinating. They force us to face a question we've never had to ask before. What happens when we build a machine that can outthink the universe that created it? Maybe the universe won't mind. Maybe it wants to be understood. Or maybe it doesn't. Because the deeper we go into quantum reality, the stranger it gets. Particles that appear out of nowhere, time that doesn't flow linearly, and information that never truly dies. We might not just be building a computer. We might be building a mirror, one that shows us what reality really is. And when we finally look into it, we might not like what looks back. So for now, enjoy your classical laptop. Cherish your memes. Guard your passwords. Because one day soon, a machine colder than space and smarter than everything might decide to run its first program. And when it does, the world will never be the same again. Hey, I hope you enjoyed the video. These videos take me a lot of time to make. So please hit that like button. But only if you liked it, of course. Subscribe if you want and tell me what you want to see next. Later.